Okay, so we're on 4.8. We're dealing with quadratic inequalities. We're going to be dealing with two different types of inequalities that look super similar, but actually have completely different techniques that we're going to use. And so I want to get you used to what the difference is from the very beginning, so hopefully we won't get them confused. So the quadratic inequalities that we're going to be doing in this first video, we're going to be graphing quadratic inequalities. What we're going to be doing here is actually super similar to graphing the linear inequalities that we did in the last chapter. So they will look like this. You will have a y, you will have all the x stuff, and then you'll have some sort of inequality symbol. Greater than, less than, greater than or equal to, less than or equal to. The stuff that we're going to be doing in our next video looks like this, for instance. So if you flip the page, you can see that. Notice this one does not have a y. This one doesn't have a y, which means we're solving it in a one-dimensional space, a one-variable space, rather than a two-dimensional space. So this would be like solving the linear inequalities that we did in chapter 1, when we were just solving like x plus 4 is less than 0 or something like that, and we'd plot our answer on a number line. That's what we're doing second. First, we're doing a two-dimensional coordinate system graph. Okay, so the way that we graph these, I'm going to give you a pretty straightforward step-by-step process here. Step 1 is to graph the related function. And the way we do that is by changing the inequality to an equal sign and then just graphing that line. One thing that you need to keep in mind is, should it be a solid line or should it be a dashed line? Make sure you're paying attention to that. This one underneath us, for example, is just a greater than, so it would be a dashed line. Step 2 is to test a point not on the parabola. Now, we love to use 0, 0, but if for some reason 0, 0 is on the parabola, you're going to have to choose something different. 1, 0, 0, 1, something like that. So what you're trying to figure out is, whoops, that should be an is it a solution? Okay, so say we use 0, 0, for instance. The reason we test it is because we're trying to figure out, is 0, 0 a solution to my inequality, or is it not? And then step 3 would be shade accordingly. So depending on the result you got from step 2, so say you tested 0, 0 and it was a solution, that means you shade the region that contains 0, 0. If it wasn't a solution, you shade away from the 0, 0. And so we'll get to see an example right here. So graphing each inequality, so a related function is y equals. Okay, so the function we're going to graph is y equals x squared minus 3x plus 2, and we are going to graph it as a dashed line, and that is because we just have the greater than, we don't have a greater than or equal to. So there are a bunch of different techniques that we've learned so far as to how to graph these. So we could use a Y-intercept, we could use X-intercepts, so there's a couple different things that we could use. We always want to use the vertex if that's available to us. So this one, our y-intercept, is always kind of the easiest point to find. You'd plug in 0 for x's. So if we plug in 0 here and 0 here, we come up with just y equals 2 as our y-intercept. So remember, that's a point 0, 2. You can do your x-intercepts as well, or you can always test to see if you could do x-intercepts. So for x-intercepts, remember what you do is plug in 0 for y. So if we have 0 equals x squared minus 3x plus 2. Sometimes it's convenient to do x-intercepts, sometimes it's not. It's convenient if you can factor this. Otherwise, it's not really worth it to go through and do the quadratic formula just to graph a quick little parabola. So here we actually can factor this right-hand side down, and it's worth a try. Worst case, you try and it doesn't work, and then we skip ahead to a different technique. So here, remember, we're trying to find something whose product is positive 2. And whose sum is negative 3. So to multiply to positive 2 and add to negative 3, that would be a negative 2 and a negative 1. And you could always refoil and just confirm that that does actually work. And then remember, we set both of these equal to 0. So set x plus 2 equal to 0, and we get x equals 2. So that would be the point 2, 0. And we can set x minus 1 equal to 0, and we get 1, so our x-intercept would be the point 1, 0. So that's going to be enough just to get the picture. So when we sketch this on here, we're going to start with these points. So I have a y-intercept at 0, 2, so that's right here. I have an x-intercept at 2, 0, so that's right here. And I have another intercept at 1, 0. Okay? You could also check the axis of symmetry by doing that equation x equals negative b over 2a. Okay, so negative b would be positive 3 over 2 times 1. Okay, so 3 halves, that'd be 1 1/2, so that's this line right down the middle here. Okay, and then we don't need to plug it in. We could if we wanted to. We're not trying to get like a super, super accurate graph. This will be enough of our picture, and remember we're making it a dotted line. When we get to this axis of symmetry, we turn back around and go up again, because remember our axis of symmetry is going to have the lowest point on it, the vertex. So that's the actual solution, the related function. So that's our graph. Next, we're going to test a point that's not on the parabola. So lucky for us, 0, 0 is not on the parabola. So we can test 0, 0. So just plug it right into the original here. So is 0 greater than 0 minus 0 plus 2? Okay, so is 0 greater than 2? It is not. So when we say shade accordingly, that means if 0, 0 is not part of my solution set, because I've got really two regions. I could either shade everything kind of around the outside of the parabola, or I could shade everything inside the parabola. The fact that 0, 0 is not part of my solution set, 0, 0 is not a solution, so I'm going to shade everything else. Oops, forgot to get crayons. All right, so I'm shading inside. Once I find my crayons, don't mind me. Okay, here we go. So this would be everything that we shade on the inside here. Okay, so actually very, very similar to the linear inequalities and the absolute value inequalities that we did in the last chapter. All right, so that would be your final answer for that one. Let's take a look at the other one. Okay, so now depending on the way that the equation is given to you, you might have different techniques. Like if you're looking at this one and you're like, factoring this seems difficult, if not impossible, you always have different techniques that you could use. So our solution, the function that we're going to graph, is just y equals negative 2x squared plus 3x plus 5. We are going to again graph it as a dashed line because this one also just has a less than, not a less than or equal to. So we could do the y-intercepts. And the y-intercept is 5. That's always just the constant that's tagging along on the end. And so 0, 5 would be our actual coordinate point that we plot. And then x-intercepts are really not worth it here because you'd have to try to factor this. So let's just go with the vertex. Okay, so the axis of symmetry, we do x equals negative b over 2a. So negative b would be negative 3, and then 2a would be 2 times negative 2. So that's negative 4. So remember, that's the x coordinate of the vertex. You can plug that in to your equation to get the y value. And this is where the convenience of calculators comes in, because all I'm going to do is plug this right here into my calculator. So negative 2. In parentheses, I put my negative 3/4. Oops, there's a glare. And square it. Plus 3, and then in parentheses, negative 3/4 again, and then plus 5. All right, so I get 1.625. So we can just approximate that. Okay, so my vertex is negative 3/4, so I can write that as negative 0.75, and this is the y value right here. So remember, you can use your axis of symmetry and your vertex to plot a mirror image of this. So let's get going here. So my y-intercept is at 0, 5, right there, and then I can plot my vertex. So I go to negative 0.75, so that's my line of symmetry right there, and you're just approximating. just guessing what negative 3/4 would look like. So you put it about 3/4 of the way over to 1. And then, again, just approximating where that value would be. Whoops, I did something wrong here. Okay, I'm sorry. Let's travel back up here. This would be a negative b, so that would be negative. So let's plug this value. I thought that looked a little bit wrong. So those are positive. I apologize. Let's plug this back in because this negative tells me that my parabola is supposed to be upside down, and that was not looking like it was going to be upside down. So let's try this again. Okay, so plug this in. I'm just going to go up here, copy paste it, and I'm going to take away my negatives. So that should be a positive. Okay, let's try that again. 49/8, also known as 6.125. That looks much better. Sorry about that, guys. Okay, so still on this line of symmetry. So up at 6, so just a little bit higher, so we're just going to ignore that point right there. So that looks much better. So now we can mirror my y-intercept over here, and then that's enough just to get the shape of my graph. Remember, it's a dashed line because of my inequality. Okay, so that's step 1, is graphing the solution. That's really the hard part. Next, we can do a test point. 0, 0 is not on the parabola, so we can test 0, 0. I'm going to plug it in right here. Is 0 less than 0 plus 0 plus 5? And 0 is, in fact, less than 5. So what that means this time is that 0 is part of my shaded region. So since 0 is part of my shaded region, I would shade everything in that portion of the graph. Okay, so this is part of my solution, so I shade everything in here. Okay, so your two regions are either like inside the parabola or outside the parabola.